Welcome to Across the Globe. Today we will learn about regular expressions advanced. Regular expressions in Python serve as a robust resource for identifying patterns and processing text efficiently. By employing advanced regular expressions, users can execute intricate tasks beyond basic pattern matching. For example, with advanced regular expressions, one can extract email addresses from a large set of data or scrape specific information from website content based on defined patterns. This versatility makes regular expressions a valuable asset for tasks requiring detailed text manipulation and analysis. Lookahead and lookbehind assertions in regular expressions allow specifying patterns followed or preceded by another pattern. In the code example provided, the regular expression Python sprogramming is used to find instances of Python that are immediately followed by the word programming. This means it'll match Python only if it's followed by a space and the word programming. This can be useful for more specific text matching, such as finding certain words in a particular context. Non-capturing groups in regular expressions help to group patterns without capturing the matched text. This is beneficial for organizing patterns without extracting the matched text explicitly. One common scenario where non-capturing groups are valuable is when matching email addresses, particularly if you want to group the domain part without capturing it. For example, imagine you have a list of email addresses and you are interested in extracting the username part, owning them, but only want to group the domain part for organization purposes without capturing it. Using a non-capturing group, you can create a pattern like pat plus. In the given Python code snippet, the regex pattern @+ home+ is employed to match email addresses where the domain part is utilized as a non-capturing group. When applied to the input text, it will extract the email addresses while only capturing the username part and not the domain part. Named groups in regular expressions enable you to assign labels to matched patterns for easier reference. They enhance the readability and maintainability of your code by providing a clear structure for capturing specific data. For instance, consider extracting username and domain from email addresses in a text. By using named groups, like shown in the presented Python example, username W+ captures the username, while pdomain W+, captures the domain. This approach makes it straightforward to access and process the captured data within your code. By incorporating named groups in your regular expressions, you can efficiently handle complex pattern matching tasks, resulting in more organized and comprehensible code that is easier to maintain. Regular expressions are like a secret code that only certain people know how to decipher. Just like how a locksmith uses specific tools to unlock a door, regular expressions use specific characters to manipulate and search for patterns in text. Think of regular expressions as a powerful search feature on steroids, allowing you to quickly and efficiently sift through large amounts of data to find what you're looking for. Using regular expressions in programming is like having a magic wand that can automatically perform complex tasks like validating email addresses or extracting phone numbers from a text file. Hey, code conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. Regular expressions are a powerful tool for manipulating text data in various programming languages. In this Python code snippet, we are utilizing the module to leverage regular expressions functionalities. First, we initialize a sample text that we want to search through for a specific pattern. In this case, we set text to a sample sentence about regular expressions. We then define a regular expression pattern using the R syntax to search for the phrase regular expressions, which is the exact case of the text. To search through the text for occurrences of our defined pattern, we use the re.findAll function. This method returns a list of all non-overlapping matches in the text that conform to the specified regular expression pattern. Finally, we display the number of matches found for the pattern and list out each occurrence. Running the script would output the count of matches for the pattern regular expressions in the sample text. Regular expressions have various use cases, such as data validation, parsing, text manipulation, and more in real-world applications, making them an essential tool for handling text data efficiently. Regular expressions are an incredibly powerful tool that can be applied in various real-world scenarios. For instance, 1. Data validation and parsing. Regular expressions are extensively used in data validation and parsing tasks across different industries. For example, in the finance sector, banks often use regular expressions to validate and extract information from financial documents and transaction records. This helps in identifying patterns and ensuring data accuracy. 2. Text mining and natural language processing. In the field of text mining and natural language processing, regular expressions play a crucial role in information extraction and sentiment analysis. Companies specializing in customer feedback analysis or social media monitoring utilize regular expressions to extract key insights from vast amounts of text data. These examples showcase the versatility and importance of regular expressions in handling and processing text-based information efficiently in various industries across the globe. Keep learning, stay curious, and I'll catch you in the next video.